Yeah, our last speaker in this session is Rajesh Kalyanam, and he's going to be talking about data-driven collaboration environments, specifically about integrating HUBZero and iRODS.
All right, thanks, Mike. So you've heard several plugins for this work through the talks this morning, and I hope I'll live up to the hype. So this is essentially a fancy way of saying iData. So data-driven collaboration environments is our effort in, I'm sorry about that. So it's essentially our effort to integrate the collaboration support that HUBzero provides us with essentially data management systems. So in this case, it's iRODS, which is a distributed data management system. And so I'll start off with some of the history of how this development took fruit and go into how we are sort of working this into the GAPS project, and then finally talk about a more tightly coupled integration between HUBzero and iRODS, how we are trying to work towards that. So here's a brief history of this project. So as you all know, there's been several hubs that have been created in the past. I say like 100 to 200 hubs probably. And the good thing, I mean, the success story here is that it allows you to bring together researchers from around the world who sort of collaborate and then solve real world problems. So I've just had two examples of hubs here. So GeoShare and DryNet were essentially hubs that brought together people from very diverse fields. So agricultural economics, agricultural climatology, environmental engineering, and so on, and they were working towards using different kinds of data, so essentially geospatial time series data from different fields, such as land use, climate change, climate modeling, environmental studies, and so on, and they were trying to predict the effects of droughts and these different environmental effects on crop yields around the world, and trying to improve crop yields in different countries, for example, Africa and India, and so on. And so this picture here is sort of a very broad overview of generally the use of any particular hub, but in this case, these two hubs. So you have researchers here who are they have their own different kinds of data files. So I don't know, you can see that. So it's essentially time series and geospatial data in addition to other files. And they want to share all that data with other researchers around the world. They also want to contribute processing tools and use these tools in conjunction with the data and run simulations and see where that goes. So this is a broad list of sort of the different things that you would want from such a hub. So you want to be able to manage, access, and share your data with other users. You want to be able to run tools on this data. And especially with respect to geospatial files, you want to be able to preview your data really quickly because you have an actual static file living there and you want to be able to look at it real quick and then see what's in the file. And finally, you want to be able to compare data from different sources. So you could have researchers from different locations who are sort of working on the same project. They have their own simulation tools, they're running it, and then they have some tool output, and they want to be able to compare the results, see which model performs better. And so the first step towards all this was sort of providing a data management framework. So iData was essentially intended as this data management component that allows users to come in and then share the data with other users on the hub. So it's essentially behind the scenes just a regular hub web component that allows users to upload the data and then organize them into familiar nested folder structures. And you can go in and then use hub support for collaboration and security and so on. So you can actually turn on the file sharing based on the actual hub groups that are present on the hub, and then set different permissions for different hub groups and so on. And also another important thing is the support for metadata. So you can go in and add your own metadata for these different files that are living in iData, and that is then translated into search for files based on the metadata that's stored. And again, finally, since we're talking about geospatial files, we have support for previewing geospatial files and running simple post-processing operations on them. So for example, if you have a raster file, you may want to resample the raster file to a different resolution, or you may want to reclassify your raster file so you have a more compact view of your data. So you may want to just classify it into two different classes rather than have a whole real number space for your data. And again, in the case of tabular data, we have support for essentially importing your CSV files into a database that lives on the hub, and then you can actually run queries off of that database or filter your data in the table and then subset the data and so on. So this is essentially some screenshots of the iData interface. I don't know how clear that is. So on the top right, top left there, you have just the file listing. I think you've seen it in the previous presentation as well from Haojin. And down here, you have the tabular data support, which is essentially a listing of the different fields that you've from the table that you've imported into the Hub database. And to the right, you have the different geospatial preview features in iData. So once you upload a geospatial file, for example, a raster or a vector file, then you can actually go in and request the file to be previewed, and behind the scenes, it imports it into GeoServer, which is a geospatial management software, and then it actually allows you to preview the file with associated style sheets. So the top there, you actually have a raster file that shows crop yields around the world. And then this is essentially the support for reclassification. So the same file there can then be reclassified into just 2 classes based on whatever filtering you want to apply to that. OK, so that's essentially the iData web component. So behind the scenes, all of these files are actually stored in iRODS, which is a distributed data management system that allows you to essentially abstract the actual physical storage away from your application. So it was developed at the University of North Carolina, and they're still maintaining that. And so one of the advantages is that it has support for easy expandability. So you can actually go in behind the scenes, add new disk space. You can move around your actual physical files, and then the top abstraction doesn't really have to be concerned with that. You can manage it pretty easily. And the metadata that I was talking about before, that's actually stored along with the file in what's known as the iRODS catalog. It's off to the left. So iRODS essentially has a catalog server that allows you to have metadata associated with the file, and it supports search across that catalog. So you can actually search for files with metadata matching whatever queries you want to enter, or just regular file search strings. And finally, the main big selling point for us was that iRODS actually has a PHP client API. So that makes it really easy for you to integrate it with your Hub components, because it's all built on PHP, and then you can just use the PHP client APIs to talk to iRODS. And so iRODS essentially functions as our file management server, sort of, and then we just use the client APIs to sort of talk to that to either download or upload files or access metadata or run queries across the metadata. So I'm going to jump real quick into our work in GABS. So you've heard a lot about GABS this morning. And essentially, we wanted to bring in iData as sort of the central clearinghouse, or the central clearinghouse for data for the GABS project, so that we could have the central data repository and then have interoperability with that with all the other different parts of the hub. So essentially, if you have a hub tool, then we would like to have this function as both the input and output destination for those hub tools. Or if you wanted to start off a publication, then you should be able to get your collections into iData and then start off the publication process from that step forward. So going into more detail with the tools, so you want it to function as both the input source and the output destination for a tool, but then you also want to enable tool discovery. So if you have, say, a couple of files in your iData interface, then you want to be able to figure out what tools can be run for each of those files. And you've seen that before with the GeoBuilder tools. You can actually see a link next to the file that says that you can launch the GeoBuilder tool for this particular file. And finally, just tool provenance. So if you're storing tool output data back into iData, so how do you ensure that you have all the information that you need? So for example, one big thing in tool outputs is that you want to be able to reproduce that result. So if you have different researchers coming together and someone has produced a tool output by running a simulation tool, you want to be able to reproduce that result. So you want to have as much metadata as possible with the tool output files stored back into iData. And again, with the theme of GABS, you want to be able to support geospatial search for your data files. So you want to have geolocations and then search across those locations. So iData and hub tool integration. So this is essentially just our initial stab at this work. So how do you integrate iData, which is our data repository, with the tools that are already there on the hub? And this actually shows you 2 modes of this integration. So on the top here, you have a tool that's actually running in the tool workspace session. And how do you pull in your collections from iData? So that there shows you the list of collections that you have available and shows you a listing. You can select the file and then actually download it to your local workspace session and then run your simulation tool on that. And the picture here, as you've seen before, is essentially the iData interface, which is a web component that has a list of files. And next to the files, you actually have these different buttons that tell you which tool can be launched off of that file. So you have 2 different tools here, GeoBuilder and the Active Learning Modeler tool. So how is all this accomplished? So the main thing here is we use the Hub support for API controllers. So API controllers allow you to expose your component methods as web service methods so that you can have another application that just goes in, invokes the service methods, and then does whatever it needs to be done. So in the case of iData, all you need is to have service methods that allow you to browse through your list of collections, list of files in the collection, download a file, upload a file, add metadata, and so on. And so we have service methods for each of these, which are essentially just the components methods exposed to service methods. And so that's one direction. And then the other direction, launching a tool from iData, the way that happens is the hub allows you to specify additional URL arguments when you're launching a tool. So you can actually specify the object identifier for your file that you want to be used as a tool input. And then the tool, when it's launched, can then go in and look up that identifier and then actually invoke the service method for downloading the file from iData. So essentially streaming the file based on the identifier for using the service methods. Right now, that's a very simple integration workflow. So all you can do is just have a tool that's launched with just a single file there. So we haven't yet worked on launching tools with multiple file inputs, but it's a start. So going back to what I said about metadata. So if you're actually going to be saving tool output files back into iData, you want to be able to have as much metadata with it as possible. And we have had metadata support in the past in both the GeoShare and the DryNet hubs, and we ran into a couple of issues. So the first thing is we just allowed users to go in and then just enter whatever attribute value pairs they could think of. And that's well and good, but then the problem you run into there is that you don't have a fixed schema, so what do you run your search against? How do you know that it's actually good metadata that you want to run your search against? And the other extreme is if you actually provide a form for the users to go in and fill the metadata, then they don't want to do that. I mean, you don't want to have like a 40-field form and then sit in and enter fields for values for each of the fields. And it's particularly bad if you're actually saving back tool outputs because users often write tools that try to capture as much metadata as possible. So they expect you to have the metadata extracted when you're actually saving the output file back. They don't want to go in and enter the metadata again. So the way we got around that was to use this feature of iRODS, which actually allows you to attach hooks based on events that are triggered. So for example, you can go in and attach a hook for the event that's triggered when a file is uploaded, and you can ask it to go in and then process the file that's just been uploaded and extract the metadata. So on the top there, you actually have the event which is called AC post proc for put, which is essentially the event that's triggered when a file is uploaded. You can add a bunch of conditions so that there is essentially just filtering it based on the file path and run off different methods, which they call web microservices. And essentially what that does is that it then goes in and then processes the file that's just been uploaded, extracting metadata. And we currently do this just for geospatial files and for a very restricted set of formats, so shapefiles, GeoTIFF, and netcdf files. And so we can just use the GDAL-C APIs to process the file, get as much information as you want. And that typically includes things like the variables that are stored in the netcdf file, the features in a particular shapefile, the geospatial information such as the extents and your projection and so on. And all of that information is then indexed into Solr, which is Apache's search and indexing system. And all the text fields go into the index, and the geospatial extents and so on essentially go into a coverage field, which is supported by Solr, allowing you to search across geospatial bounds. And the top left there actually shows you the metadata page, and we still allow users to go in and look at the metadata that's being captured. They can change some of it, they can add new fields, but then you don't really have the responsibility of going in and putting in as much metadata as necessary, because we do some of that work. And then the bottom here actually shows our search interface in iData. So you can either enter a simple keyword regular expression there to search for files matching that, or you can go in and select a region on the map and then look for all files that intersect that region, essentially. And all of that is done by Solr. OK, so going forward. So until now, all of this has been restricted to the actual iData web component. And what we're trying to do here is sort of have a much closer integration with Hub, between Hub and iRODS. And so the first step there is to include iRODS as another storage option for Hub project files. So in addition to iData, any Hub that comes in typically has its own support for projects and files area and projects. And so we want to be able to add iRODS as a storage option for Hub project files, and then offload any large file transfers to the actual iRODS desktop clients that are provided. And the next step there is to actually explore using Fuse. So Fuse actually allows you to mount a remote storage as a local folder on your file system. And so rather than going through all this trouble of writing wrappers in PHP for your iRODS collections and so on, we want to be able to mount the iRODS collection directly as a local folder in your Hub web server. That then simplifies everything. I mean, if you want to work with the Hub tool, then you don't have to go in and then talk to the API web service and then come back and stream and so on. You can just mount it on your tool basically the tool workspace session, and then just access those files like you would a regular local file on your system. So that's something that we're really excited about, and we're trying to get that working. And then again, just taking advantage of the metadata support in iRODS. So how do you enable search essentially for hub files or hub resources by storing the metadata in iRODS, so essentially bringing together iRODS, Solr, microservices to enable search. And this last thing here, sorry about that. This last thing here is essentially using microservices again for something other than metadata capture. So I don't know how many of you have seen this, but you can actually go into Hub project files, and then you can actually look at the compiled preview for a file. So if it's an image file, you can look at a snapshot of the file. So that's another use for microservices. So you upload a file, take a quick snapshot of the file, and then show that as a compiled preview rather than going through the trouble of, say, putting it onto GeoServer and the whole workflow there. So this next thing really is very optimistic. You could say it's a pie-in-the-sky dream, but essentially, I was thinking of using iRODS Federation to sort of allow more collaboration, so essentially collaboration between hubs. So you have iRODS working as your essential storage space on a hub, and iRODS actually allows you to federate two different iRODS servers, so you can actually allow access to files from other remote iRODS zone in a certain restricted manner. So if you had, say, one hub which was talking to its own iRODS, another hub talking to a different iRODS, you could federate the two iRODS servers together and then allow crosstalk between these two hubs. So you could even enable workflows between hubs. So you have a tool that's running on one hub, it can access files from another hub as a local file in its system, and then write output data back, which can then be used in a different tool. But that's, I don't know, several years down the line, I guess. So finally, coming back to tools again. So as I said before, iData essentially just allows a very simple tool integration. So you can go in, you can launch a tool with a single file input, or you can save a tool output back to iData. So some of the things that you want to do is essentially use iRODS metadata to allow richer tool input filtering. So rather than just filter based on the file's extension, can you filter tool inputs, say, that are restricted to a geographic region? Like, can you just choose images which have 3 bands and then just have some tools work on those kinds of files? And then again, post-processing of output data. So just like you would post-process a geospatial file and generate a compiled preview, can you post-process it and get it into more standard representations? For example, if you have a geospatial file and an unknown projection, can you reproject it to standard projections, which can be used in other tools? And then, of course, you can always use microservices to sort of put off remote data download. So for example, if your tool required, like, say, recent data from a Globus Online source or somewhere, you could have that be triggered when a microservice is run, and then have the data ready the next time you open up your tool, and then continue that process. And finally, rather than just have iRODS serve you physical files, you can input data protocols on top of iRODS, so that rather than just access the whole huge netcdf file, you can just get subsets of the data that you're interested in, and then use all the support that you have in OpenDAP and threads and so on for data subsetting. Can you put that on top of iRODS and then allow your tools to just access subsets of the data? So that's pretty much all I had, and I wanted to acknowledge the support of the GAPS project from NSF that sort of made all this work possible and is helping us go through and continue on this path forward. Thanks.